Hey guys, Mr. B here. In this video, we're going to be going over the questions in the chapter 10.5 notes. All right, here we go. Starting with number 1. How long ago did Earth form? So, this I think was mentioned in the notes, but Earth is about, or at least scientists believe that Earth is approximately about 4.6 billion years old. So we can say that Earth formed approximately 4.6 billion years ago. All right, number 2, summarize the process by which scientists determined the age of the Earth. All right, so there are a few different things, but in the notes it talked about how we use radioactive dating to look at the age of Earth rocks, as well as radioactive dating to find the age of space rocks, right, like moon rocks and asteroids, stuff like that. So we can say that scientists have determined the age of the Earth by radioactively dating Earth rocks, moon rocks, and other space rocks. Okay, so remember, remember that we think that the Earth and all the other planets and everything pretty much in the solar system, including the sun, kind of all formed at about the same time. So it would make sense that other things in space, right, asteroids and other pieces of rock, are going to be the same age as the Earth if they all formed at the same time. So if we radioactively date asteroids and stuff, it'll give us an idea of how old the Earth is as well. All right, number 3, what physical features formed during Earth's first several hundred million years? All right, so the physical features that were mentioned in the notes here were Earth's oceans, Earth's atmosphere, and Earth's land masses or continents. Okay, so you can say the physical features that formed during Earth's first several hundred million years were, say, the oceans, the atmosphere, and the continents. Or I guess, yeah, that's fine. Leave it as the continents. They weren't necessarily continents yet, but landmass continents, fine. All right, number 4. How did volcanic eruptions and comets change early Earth? So, early volcanic eruptions and comets, we think, released a lot of gas and stuff from inside the planet, which came to the surface and ultimately sort of helped to create the atmosphere, or at least the beginning of one. But we also think that there was water vapor inside the Earth that was released through volcanic eruptions, as well as comets themselves have little pieces of ice in them, and so when they land on the planet and leave behind that water, that also can evaporate into the air because, of course, Earth was really hot at the time. Then it condensed back down as a liquid later on. So, so we can say that volcanic eruptions and comets helped to release and leave behind gases that formed part of the atmosphere, as well as water. Yeah, as well as water, which helps to make up the oceans on the planet. All right, something along those lines. Oh, all right. Number 5, what caused water erosion to begin on Earth's surface? So, remember that a lot of water vapor and stuff was left behind from comets or came out of the planet through volcanic eruptions, and then it would sit in the air as water vapor, and then eventually, as Earth cooled down, that water vapor condensed and fell down as rain. And as it rained, all that water then, trickled over the land and ran over the land, which then caused a lot of erosion, and that water to dissolve a lot of minerals and rocks and stuff like that, and start to erode Earth's surface. So we're going to say something along those lines. So let's go. Water vapor in the air condensed into a liquid as Earth cooled, and it rained for a very long time, causing erosion. Something like that. All right, so let's tab this over So we can. Why does it do that? Down there. All right, whatever. Okay, so hopefully you can read that. Maybe we can move it like this. I just don't want that to be over the Pearson logo, so we can't read it. Okay, something like that. So water vapor in the air condenses as liquid, rained for a long time, and that water then eroded the surface of Earth. All right, number 6. What do scientists think were the first organisms to evolve on Earth? So some of the first organisms on Earth we think were single-celled organisms, kind of similar to bacteria like we have today, and that they first formed in the oceans near like hydrothermal vents. So we will say that scientists think that the first organisms on Earth were single-celled organisms similar to bacteria that we have today. They formed in the oceans near hydrothermal vents. All right. All right, last question, number 7. How would Earth's atmosphere be different if organisms capable of photosynthesis had not evolved? All right, so this is a really good question. Remember that early on in Earth's history, it did have an atmosphere of primarily water vapor, carbon dioxide, and some other gases, but there was really no oxygen. So all the oxygen that is in our atmosphere primarily came from organisms that could do photosynthesis. And these organisms were primarily cyanobacteria, or single-celled bacteria in the oceans that learned how to do photosynthesis first. And in that process of photosynthesis, remember, they take carbon dioxide and sunlight out of the air, and they make food, and one of the products they make in that process is oxygen. So over a long period of time, they produced a lot of oxygen, which then eventually built up in the atmosphere to do two things, okay? Remember, one, obviously, complex life like us need it to breathe. But two, oxygen gas also makes ozone gas, which is a gas high up in the atmosphere that absorbs a lot of the UV radiation from the sun and essentially allows for things to live on land. If we didn't have ozone in our atmosphere, we could not live on land because the ultraviolet radiation from the sun would essentially like bake you with radiation and you would die within a few years from radiation poisoning. Whereas if you live in the ocean, a lot of that ultraviolet radiation gets absorbed or blocked by water. Okay, so Earth's atmosphere would be different because there'd be a lot less oxygen in it and a lot less ozone. Okay, so we can say Earth's atmosphere would be very different because there would be little to no oxygen gas in it, as well as no as well as little to no ozone gas in it. Both of these gases are essential for life to thrive on Earth. All right, something along those lines. All right, guys, I believe that is it for this section of notes and these questions. After this, you should be moving on to your chapter 10 review guide and then taking your test. So if you have any questions, as always, please reach out to me, and I'll see you in the review guide video. All right, bye.